Hello, this is the presentation for the data vision with artificial intelligence activity. This is team 2, and the main idea is to create alongside with the smart coffee inspection system and Scada 0.40 and that works with artificial intelligence to solve decision making. And these are team members. It's José Luis Patricio Orozco, Ari José de León, Iván Eduardo Vargas, and Juan Carlos Castellanos. And just for some context, the idea is to develop, design, validate, and build a prototype capable of optimizing the current industrial process that is for a pick and place routine of coffee. The idea, the objective is to eliminate crushing and pitching risk for the operator while ensuring product quality. The project or the simulation must include real-time industrial status, artificial intelligence analytics, predictive alerts, optimization recommendations, sub-instructions, and pass or no pass decision based on the state of the cafe. And this must be aligned with the client needs and the project goals boundaries.
Our general objective. In this project, we will present what is the development of a Scada system capable of monitoring, analyzing, predict, optimize, and assist the caffeine retrieval and inspection process in real time. Why Scada? This will allow the operator to monitor the happening process in real time and take more efficient decisions. The tool that we will use is Scada 4.0 with AI that will help develop and take more intelligent decisions. This system is capable of making logical decisions according to the receiving information that will come from the semi-automated retriever and the inspection process. What we have next is our material flow diagram. In this case, first we will have what is our coffee input, where it's going to enter in gravitational conveyor. Then we will have our proximity sensor that we will activate at the end of the gravitational conveyor. This will give sequence to the second part, that is the manipulation process, where the Lexium cobalt will take our coffee with a magnetic ripper and take it to the retrieving area. In the retrieving area, we will going to have what is our execution, what is going to be where the retrieving process happens. Then we will take a proximity sensor that is going to tell us when the coffee is all ready, and we'll get our cognitive inspection. This, with AI patterns and tools, will help us realize if the coffee is completed or have some errors. And our last part will be the quality OK, where the correct piece fixture will get into OK box or do not OK box, besides what is going to happen. Our digital twin. As we can see here, we have what is our gravitational conveyor that is going to pull it down. Our coffee is going to take it and put it on the coffee holder. Here we have the retrieval and inspection, and then it's going to choose in which box it's going to get. This will be OK or do not OK.
Now talking about the artificial intelligence pillars that the Scada system will have, these will be 4 main roles and based on 5 pillars, which will be the watchman, the mechanic, the optimizer, and the coordinator. Each one will have, for example, watchman will be pillar 1 and 5, mechanic pillar 2, optimizer pillar 3, and the coordinator will be pillar 4. The idea is that for example, talking about the watchman will be in charge of detecting anomalies and security issues, meaning that this role will be in charge of, based on any issues, creating an alarm and contacting the operator to solve it. Then the mechanic will be the one that is in charge of creating prediction maintenance problems, meaning that the mechanic will be the one that will solve the mechanical part of the system based on the sensors and the information coming from the system and stored in the Scada system. While the optimizer will be the one that will complete a basic but important part of the Scada, which is to create or to obtain the optimal parameters, which will create or minimize the time and this will help to obtain the goals of the system. While the coordinator will be the one in charge of giving sub instructions and operator guidance.
Now we open our Machine Expert Basic program, where we begin by selecting an R model Schneider PLC, which allows us to use its Ethernet connectivity in order to send its data through Modbus into our Node-RED. Now we move on to our ladder diagram, where we program the PLC to act as a state machine, where certain signals are used to activate memories that act as a sequence indicator for a Node-RED dashboard, which also include which actuators are active, like the gripper, as well as if the robot is currently in a certain zone, and the camera's trigger and pass and fail signals, and a reset button in order to consider all of the buttons we are to integrate into our dashboard.
And I will present the Node-RED. This is our architecture. First, we have the reading data. Here we have our main page. That is our dashboard. This is the code. We have detect M40 and M41. That's our end of the cycle. Those two are memories. M40 means that the coffee it has no issues, so it can pass through the process. And M41 is another memory that represents that the coffee has some issues, so we need to put that coffee on the batch with the bad coffees. We have our AI here. This is our key. We use the post so we can have the response on the AI. Here we clean the response so we can have short messages. Here we have our Firebase connected. This one is our link. And we have the request. We used a put so we can add information of the coffee, the output result. So for running this code, we have this dashboard where main focus was on the process monitor. That is just like something we want to add, and it's just a general review for easy to see and easy to play around. So we're just gonna make a quick example. If we start the program, this will start going up and it represent each step. For example, we have 9 steps. Right now we're on the number 3. Number 4 steps has a small explanation. And on the 7th step, we need to make a decision. The operator needs to review the CAFE and determine if it's correct or incorrect. For example, in this scenario, we will make it incorrect. So we press incorrect, and the piece is already not passing. Here we have the whole cycles. How many times have we made the process? How many times the copy has been correct? In this case, we haven't made one piece correct. And we have one no pass copy. So that thing we just did. Here we have all the PLC memories when it's turned on, when it's turned off. See, so we're like whole map of the memories. Then we have the student watchman. It's pretty cool here. So here we can watch the whole process in real time and all the process that we already been through. Right now, it's running. Here we have the whole steps. Sensor 1, it's detect the coffee on fixture 1. Cobot goes to fixture 1, gripper on. This is the whole process that it is following. Then we need to make the decision again. We're gonna make correct coffee. And here it says correct active, correct coffee position at the final. So right now we have these two cycles, two tests we already did, one pass and one fail. So let's move on to the student B, the mechanic. This one, it's my favorite. Here we have the total cycles, how many times the sensor one has detected the coffee, how many times the sensor two has detected the coffee, uh, how many times the cobot move to the fixture one, fixture two, fixture three, and how many times the gripper has turned on and off. For this example, we're using an electromagnetic gripper. And this one is the status, the current status of the cobot. The position idle is turned off. The gripper, the engaging, releasing, this is like the whole status. And this is a pretty cool part where we can see how many times we have used our equipment. So for example, our cobot, we have used it two times in this example that we just start using it. And we have a predictions of 10,000 cycles. This information was searched in Google, so we can have like standards. And this one is for everything, sensor one, sensor two, the gripper, the vision system, like for everything that we have on the station. And if, for example, we have used already 900 times this the vision system, this will have a message that will inform us to review the equipment and give maintenance. So that's pretty cool. Then we have the student C, the optimizer. This one is also pretty good. I really like this part. So here, let's run it. We have the time running. It's already starting. It has 3 seconds, 4 seconds, and it will go on until the process is done. So here we have optimal target of 35 seconds. That's like the normal time the operator will make everything of this process. We're gonna put correct, and we're gonna finish this process with a score of 100%. Why is what 100%? Because we are inside the optimal target. But for example, let's do it again. Let's run it. And we're gonna take more time so we can have another score. This one is programmed. If you take more than 45 seconds, your score is gonna be a zero. And for example, if we take right now like 40 seconds, we're gonna have a 50% of the score. So let's review it. We're just gonna take a while to input the answer. We're gonna put that is correct right now. And we have 43 seconds. And we have a score of 43, just a coincidence there with the seconds and the score. But yeah, here we have a little message, optimization and recommendation. This run was poor. And here we have some variables that we can change so we can have less time and more optimization in the process. So we can have like for example here sensor one, it's always gonna be the sensor like pretty fast, so we don't take that in account. But for example, the cobot, we can optimize the cobot. We can use like for example joint movements that are more faster than the linear ones. Um, Here we have the operator decision. That is the decision that we take And this one is variable and with a warning. So if the operator takes a lot of time reviewing the piece, we will have bad optimization problems. Here's one little recommendation. So that's the optimizer, and we are going with the coordinator. Here with the coordinator, well, first of all, we already have all our cycles approved, reject, and the last cycle, the time of the last cycle. Here we have first try, that was no pass. We took 43 seconds. It's 14 seconds, almost 15 seconds more than the standard. That's bad, and it was no pass, so it was a really bad run. But the second one, we can see here, it was a pass. We took 28, almost 29 seconds. So pretty good. This one is almost a zero. Here, the third one, we have a pass, almost 30 seconds. Pretty good. We're still on range. And the last one, the one that we took a lot of time, here we say 43 seconds, and it's on red. We add almost 15 seconds, 15 plus seconds to the original process standards. That's why it's on red, so we can like review it quickly, the bad times. Here we have a guide, like a standard guide. For example, if something is not working properly, if the cafe is misaligned, stop, reposition, and restart the whole process. Is if the cobot stop, well, release the motors, go home and restart. Vision's problems. Here we have like a whole scenario that is directly connected with this problem that it was a pass, but we took a lot of time. So here we have some recommendations for that. Then we have our Firebase. Here we have all the data. For example, these ones are the ones that we just did. The zero was our first attempt. The one and this one is our last one. Here we can see the date and the hour. It's pretty late right now. So let's just make another run so we can review is correct. Our last data is this one at 12 p.m., 12 a.m., 56 minutes and 53 seconds. So let's make another run. Let's run it. And when the piece is already done, we have ones if the piece is correct and zero if the piece is incorrect. We're running the program so we can review that. Here we go. This one we're gonna put that is correct, so we are having a number 1. Okay, we're done. Cycle number 5. And here we have number 1. Let's do another one that we are gonna make it a failure, so we're gonna have a 0. It's running right now. This one is the main page, but we can move around pages if the process is still running. Here we have our watchman, the real-time processes. We have the number B, that these numbers are just going up. We're gonna have an incorrect one, so we can have a 0 on the Firebase. So we're done. Total cycles 6. And here we have it, a 0. So that's our whole project of Scada. This is our red node architecture, our dashboard, our Firebase, and the implementation of the Gemini with the messages that are related to the status of the last piece of the piece that we just made, if it was good or it was bad.
Okay, so just as a conclusion, I think that, well, even though the current system that integrates the PLC and the vision system to create the pick and place routine with the election cobot and the cafe, even though the system might seem, well, sophisticated, or that it already integrates everything that's necessary because it has the sensors and the state space routine. The inclusion of SCADA with, for example, the 4 artificial intelligence pillars that were created in this activity, such as the watchman, the mechanic, the optimizer, and the coordinator, well, the tests that were created for this activity really identify how the inclusion of this tool, that is SCADA, really is capable of creating a more reliable, efficient, and intelligent system. Well, in this case, an inspection system. So I think that it's really important to understand how the industrial automation can evolve from simple monitoring to intelligent decision making. For example, a normal operator won't be able to analyze as much information that an artificial intelligence could do with big data, or, well, just with the monitoring of the information and storing that into the server. So, just as a conclusion, I think even though the system could have some failures, or, well, some improvements in the future, this will help us to develop the project and create a more efficient way of solving the ideas, such as minimizing time, increasing speed, or minimizing the error.
As a conclusion for this project, one of the most helpful parts was that we had an example for a deliverable in Canvas, and but it was still very challenging to create our own interface given the limitations that are present with the most high-end AIs available, like Gemini, using certain amounts of tokens and having to learn various optimization methods for for the tokens. That's something that we would have to implement if we were to create another dashboard and or program using AI.
In conclusion, as we present this challenge, we find some trouble. Well, it was like a simple idea to create a pick and place mechanism, but we find challenges with the implementation of SCADA. What was the integration of the PLC, the non-red, the dashboard, all the sensors, and that we were able to create all these advantages. One of the main one of the main things that shows how important is this kind of implementation was the idea to predict and, well, make more efficient the process, like being able to create all this feature to create it more user friendly and allow the operator to be understandable of what it's doing and what are the possibilities that can be made. Also, well, during this process, through my own words, there were challenges like the implementation of all different kind of connections, like what was the PLC, the Profinet, and all that kind of stuff. Like we were, we never worked with that before, so it was an interesting part to implement it, and also know how all these different parts complement each other's and let us create like complex system like this. Like I said before, this was very simple mechanism, just a pick and place, but with AI tools, data analysis, data acquire via sensors, via camera, via process, via all this stuff, let us know how challenging it was. And well, what we get was a more efficient, more effective, more reliable process of coffee making. Thank you.
Personally, I will say that Scada is a pretty cool tool to be used in a personal project like this one or inside a big company like Schneider. Actually, where when we go to the Schneider shop, we they show us how they use their Scada, and it was pretty awesome how people are like real time connected with all the information and being really far away. So, for example, if they have a tiny problem on the process B in the part V, the operator puts the notice, then the gerent of the plant can review it in real time in less than 10 seconds. And I think it's pretty important that we can measure stuff so we can improve it. And Scada is really specialized in that kind of mentality. So you can only affect the things that you can measure. So Scada really take a focus on measure everything and also review it really fast. I'm really grateful to the fact that I can use this type of tools in my school, and I think it's a pretty good way to continue my engineering path.